Broadcasting around the world. This is Engineering Tomorrow, the podcast committed to bringing you the best in commercial construction, design, and engineering from the brightest minds in the industry. This is the stuff they don't teach you in school. So sit back, relax, and open your mind. You're about to get the insider knowledge to improve your next construction project or advance your career. This is Engineering Tomorrow.
Hey everybody, welcome to Engineering Tomorrow. As always and every week, I'm your host, Brian Gomsky. And today we have two very special guests. First, we have Brad Carl, who is famous in the commercial boiler world with Camus. And then we have Jeff Henderson,
hello,
who is the St. Louis sales manager and industry veteran in commercial HVAC. And we are here today to talk about boilers, specifically Boilers 101. What is a boiler? Types of boilers, boiler loops. By the end of this episode, you will be armed with everything you need to know about getting your feet wet with commercial boilers. Gentlemen, welcome for being here today. Thank you.
Thank you. Thank you. Thanks for having me. I don't know how famous I am. Notorious in my own mind.
Within the boiler industry, you're very famous. Trust us. Brad, give us just a real quick rundown on who you are and your expertise with boilers, and then we'll just jump straight into Boilers 101.
Yeah. Brad Carl. I'm the regional sales manager for Camus Hydronics. A little bit about my background. Started in the industry selling boilers. Moved on from that to work for a contractor. Decided that I wanted to go on to the manufacturing side. So about 12 years of experience in boilers on all sides of the industry.
Okay, cool. Just starting out, since this is Boilers 101, what is a boiler?
Yeah, boiler. It's a medium for heating water. Whether it's water or steam, and I guess in regards to our product line, it'd be water, but used for whether it's a process or heating application.
Okay. So we got a big machine that heats water. What is its, for Camus's purposes, what's its heating medium?
Primarily, we use water. It also can be glycol. We have glycol systems, especially where we have extreme low temperatures. There's a lot up north where I'm from in Minnesota. I'd say that there's a good mix of both water medium and glycol medium.
And these are all predominantly gas-fired, correct?
Gas-fired, propane-fired. You're going to see boilers on the market that use other alternative fuels as well.
Okay. So what are you hear a lot about, like, what is, you hear about fire tube boilers, water tube boilers. Can you explain the difference between those two?
Yeah, I mean, it's pretty easy, right? So you have water tube and fire tube. Water tube signifies that there's water in the tube, and fire tube signifies that there's fire in the tube. Now, there's a considerable difference when we're talking about these, right? If we look at the volume of water within a water tube or a fire tube, let's just call a 2 million B2 boiler. If I have a 2 million B2 boiler in both fire tube and water tube, I might have 15 gallons of water in that water tube, but I'll have 115 gallons in a fire tube.
And what are the different reasons or applications you choose one over the other?
Yeah, so as you can tell, that 15 gallons is significantly different than 115. So these boilers are going to require a different piping schematic or a different piping strategy, right? So we have primary, secondary, we have primary, variable. A water tube is with 15 gallons requires a restricted flow. So we want to maintain a safe delta T. So we require a pump to be dedicated for that boiler. That pump is going to be designed for what delta T we're trying to maintain. So given the model size, you could be anywhere from, 20 degree delta T to 40 degree delta T, but that pump is going to be a constant pump. In regards to the 115 gallon fire tube, it gives us the ability to get a better delta T, right? We can, in a lot of cases, we can do anywhere from 20 to 80 degree delta T. Mm-hmm. And it makes it ideal for that variable primary type system where we can deliver the BTUs that we need without having to run a constant pump. Your system pump is going to be just fine for driving that water through the boiler, and we're going to be able to maintain the loop temp or whatever temperature you're trying to achieve in that system.
Gotcha.
To chime in real quick, with water tube boilers, you have a very small mass of water that's in your heat exchanger, and you have very small tubes, and if you don't have enough flow through those tubes, you will, steam off or flash off that water, and you will damage, or crack a heat exchanger, which is why they require a pump to ensure that you have that flow through the heat exchanger.
In fact, I guess a tip when you're looking at, especially if you're doing in the replacement business and you see pinhole leaks in copper, a lot of times it was maybe ran on a tool over pressure, and what happened is it forms a thin layer of steam across that tube, and that's what causes a lot of times pinhole leaks. It could also cause from too fast a flow. If you're running too high of a flow, you're not going to get as much delta T. We're not pulling out that heat. Keep in mind, we got a flame that's 1,500 degrees. So, and if we only have 15 gallons, that flow needs to be pretty precise to be able to maintain that safe delta T.
Jeff, are we seeing? Is it application specific, or are we primarily seeing one version over the other? Mostly.
It is application specific. Retrofits tend to be primary and secondary because, the older boilers had to be piped that way because they're older, water tube boilers. The newer boilers, when you're designing fire tube, we tend to see a lot more often as variable primary.
And that's, I think, a good thing to keep in mind, right? We walk into an old building and we've got rebates, and everyone wants to get a rebate on their boiler.
But for sure. But
the question is that system designed for a condensing application? I walk into buildings all the time, and if you're pulling out a boiler that was designed for a 160, 180 type application, there's a good chance that every piece of equipment out in that field is also designed for a 160, 180 application. You could put a condensing boiler in and you can creep up the water temperature to try to see if there's savings there. But maybe the best route is to replace it with an 85, or if it's possible and there's not a long stack run, put an 88% in, see if the payback is available, and use that money to save in another spot. In a new construction, I absolutely would design around the energy savings that we can. But that's not always the wisest decision on a retrofit.
You guys mentioned condensing. Tell me what that means. What are the options when it comes to condensing boilers? Yeah,
there's a wide plethora of condensing options, from the smallest amount of BTUs all the way up to 6 million, right? And we have it in both water tube and fire tube. In regards to condensing, let's start with the basics of what condensing is, okay? And then we could talk about the nuances of the condensing boiler and where those can fit into whatever application that you're trying to meet. So how we make a condensing boiler condense, it's not if you're looking at a pamphlet, and it could be our pamphlet or anyone's pamphlet, and you see 99% efficient, that I don't know if I want to be in the building that's 99% efficient on their boiler, because it's going to require extremely, extremely cold water temperatures at part load, right? We're not even at full load to get to 99%. So we're talking, 40, 50 degrees. I haven't been in a building that has a 50-degree return that's comfortable, right? And nor do I want to be. So we're looking at a practical application on a condensing boiler. We're looking at 92%. Right, 92, 93%. You probably get more in the summer, but in a real winter load, if we're running 100, 110 degrees, 92% is pretty decent. And how do we achieve and maximize the amount of condensing? Well, I guess if we're gonna, let's look at this from what a boiler is. We're heating water, and so we've got when we burn fuel. Right, and I'll bring it to what's called stoichiometric combustion. Right, it's perfect combustion, and it's achievable in a lab condition. We're not going to see that out in the field, but the important principles of stoichiometric combustion is that you get three things: you get CO2, you get heat, and you get water vapor, right? So those are the three main components of stoichiometric combustion. Now, the heat's going to go into our boiler, and that boiler is going to warm up, and we're going to be able to get 88% efficiency. And out the stack is going to be the CO2 and the water vapor.
Okay.
That water vapor carries both sensible and latent heat. And that latent heat has 970 BTUs per pound of steam that we create in latent heat. What we're doing is we're pulling out that latent heat from the combustion process, and that's where we're able to achieve a greater efficiency. Now, that efficiency is going to be 100% based on dew point. And dew point can change due to external criteria. But for this discussion, 135 degrees is dew point, right? So what that dew point means is I have to have below 135 degree water temperature to even condense. So if I want to be at 92% based on 135 degree dew point, I'm going to have to bring back probably 110, 115 degree water. So the cooler the water we can bring back, the better our efficiency is. That's why in a water source heat pump application, a condensing boiler is a no-brainer.
Sure. Jeff, you have anything to add to that?
No, just that, water source heat pump applications is a good comment because we do a lot of those, and we consistently use condensing boilers, and you see those savings when you use the condensing boilers in that application. But retrofit applications where they have an old boiler with coils that are requiring 180 degrees, it just doesn't make any sense.
Right.
Another thing we see a lot in terms of talking about like boilers 101 are the different types of system loops. So we hear primary, secondary, we hear variable primary. Can we go over what those two are and
Absolutely.
when to use those applications?
Absolutely. So primary, secondary, I think is going to be the most common system that you're going to come across
Okay.
in a building that is being retrofitted.
So
right?
walk me through when you see like a diagram of a primary, secondary, what does that look like?
You have two separate loops, right? You have a primary loop and you have a secondary loop. There's people in the industry that will call the primary loop the building side. I'm a boiler person. It's always going to be primary loop is boiler, right? So for this conversation, boiler primary. You have your secondary loop, which is going to be your load loop, where it's going to have the system pumps that are going to be on that load loop. On the primary side, each boiler that you have is going to have its own dedicated pump. So if you have 3 boilers, you're going to have 3 pumps. Each pump is going to have its own dedicated pump. What that is allowing us to do is make sure that we have the flow that's required for that boiler. That's why if we do any type of water tube, we want to see that in a primary, secondary application, because we can design and choose a pump based off of what our manufacturing engineering has tested and has certified. And that pump is going to be able to maintain that safe delta T that we need across that heat exchanger. If we put a water tube into a variable primary, once again, to bring it back to the beginning of our conversation, if I have a 1500 degree flame, I don't have that much of a lenience in my flow rate. So putting a boiler into a primary, secondary is going to ensure that proper flow that we need.
Okay. What is a variable primary system?
So variable primary is going to be let's talk about the primary, secondary first. So you had the primary, right? So the primary had its own dedicated pump, and then you had your secondary loop that had the system pumps, right? And those could be or could not be, depending on how old your boiler system is, on a VFD. And on a variable primary, we're eliminating that primary loop from that primary secondary equation, right? So each boiler is not going to get its own dedicated pump. We're now putting the pumps on the system on a VFD, and we're going to put isolation valves on the back of each boiler, and we're going to, as the rate or the flow increases or the load conditions change, we're going to increase or decrease that flow, and that is where the variable primary comes in. So each boiler is going to have an isolation valve on the back of it, and as we need more capacity, we'll open that isolation valve, and we'll put fire into the boiler, and all the flow is going to be driven by that primary pump, that system pump that was on that secondary loop on a secondary system.
Okay. Now, tell me, between these two loops, tell me the benefits, positives, and negatives of both.
Yeah, I mean, the primary secondary is a tried true. I think it's the only option when it comes to any type of water tube boiler, right? Mm-hmm. It's you do have a little bit more of a maintenance concern with an extra pump on each boiler, but pumps are pretty reliable, and if you're designing a system at an N+1, right? If you have that ability, if a pump goes down, you still have full capacity available, right?
Sure.
In a variable primary, we're eliminating that electrical draw, that we're eliminating that maintenance item on those primary pumps, and we're also being able to drive and theoretically put only the heat that's needed to maintain that building, right? Because you're going to be driving that flow based off of what that system needs, and then our pumps and then our boilers will respond accordingly to what the flow or what the requirements are for that building. So efficiencies, you can't get much more efficient when it comes to a boiler system than that variable primary.
Jeff, what are you seeing in terms of loop design and choices on that front?
Over the last 5 to 10 years, it really has switched from primary secondary to variable primary with the advancements in fire tube boilers. Mm-hmm. 10 years ago, 15 years ago, you were looking at 10-to-1 turndowns on most boilers. And nowadays, you're 20-25 turn down on fire tubes.
What does turn down mean?
Sorry, turn down is how...
This is the 101 class, Jeff.
Yeah, sorry. So turn down is how low can your boiler fire. So if you have a 10-to-1 turn down, your boiler can modulate down to 10% fire rate.
Okay.
So with those kinds of turn downs, if it's a spring day and you only really need, one classroom or one corner of an office that needs heat, you can turn down your boiler to where it's barely firing and only using the energy that it needs to use to heat that one classroom. So
it's literally turning it down.
Literally turning it down.
Gotcha.
Yep. So with advancements in the high turn down, we're able to realize the pumping savings by going to variable primary.
Gotcha. Okay.
So to answer your question, we are seeing, on brand new construction, it definitely is geared more towards variable primary these days.
Now, is there a lot more controls requirements on the variable primary for that, or how does that work?
Well, I'll hop in first and then let Brad kind of expound on this. There is, with primary, secondary, usually your boiler will turn on, turn off their dedicated circ pumps. Mm-hmm. So they turn on, turn off, and the boiler controls them. And then you got your main secondary load pumps that are controlled separately and going through the whole system. It's pretty simplified. With variable primary, instead of pumps, each boiler is opening and closing its dedicated motorized control valve to allow flow through the boiler or not allow flow through the boiler. You will also need a bypass out in your system at your load so that you can maintain flow through your system should there be a scenario where all of your users are satisfied, meaning if the building's warm enough in every area and all of their individual valves are shut, you still need flow through your system. So you need a bypass out there with a control, sequence for that bypass to open in that scenario. You also need to make sure that you maintain flow through your boilers, which may require a control sequence to have one boiler remain open even if it's not firing, or the installation of a bypass at your boilers as well, so that you have a path for water on both ends of your system. So those things do make it a little more complicated than a primary secondary system. Mm-hmm. But those are things that can be overcome.
As long as you're maintaining your minimum flows, it works out pretty well. I mean, it really just look at your manual and look at your equipment and figure out where your minimum flows are for not only the boilers but the other equipment in the field, and you'll be fine.
Okay. I don't want to get too, Brad, we want to have you back for more episodes, so I don't want to get too deep into the weeds, but is there anything else before we talk about Camus specifically, like from a 101 perspective, is there anything else we would want to cover about boilers? We
could do it for another podcast. I'd be okay with that. But I mean, there's a lot of ground that we can cover. Between non-condensing, near condensing, condensing, stack requirements for these boilers. If you're looking what type of boiler, I mean, there's hundreds of boilers, and every boiler has its own requirement in terms of piping.
How about sealed? Well, one thing we also hear a lot is sealed combustion. Tell me about that. What is that versus non-sealed combustion?
Right. So sealed combustion is just directly ducting your outside air directly to the burner.
Okay.
So the burner needs oxygen to be able to combust efficiently. We're bringing a direct line from outside air to the inlet of that air of that burner to provide the optimal amount of oxygen for combustion. The other options are for louvers and walls, or you can do a pressurized plenum as well with our boiler. My preference is sealed combustion personally, because I know that air is going to get to where it needs to get. You can always do a high-low louver in a building, and if that's what is existing, that certainly will work. I just find that it's cold in the middle of winter, and someone comes and shuts a louver because they want to try to warm up that space, and now we're starving that boiler for oxygen.
Is there any reason to not always by default do sealed combustion, or?
Well, certainly. I mean, if you don't have ability to get clean air, right?
Okay.
Right. If you're, if you don't have good quality air, or if you're worried about the circumstances of where you can bring that duct or that pipe or whatever you're bringing that air back, you can use louvers or you can use the plenum, but there's always applications where sealed combustion isn't going to be able to be the best solution.
Gotcha. Okay. And then the other thing, just to circle back, what is so we talked about condensing. What are we talking about when we talk about near condensing?
Yeah. Okay. Well, near condensing is one of those.
It's like close, but not quite.
It's almost an oxymoron in some ways, right? So condensing, I guess the best way I can explain a near condensing is it's a boiler that we're taking it to the absolutely maximum amount of efficiency we can get in the boiler without condensing. However, because we're taking it to the brink of condensing when it's in the boiler, it will and can and will condense in the stack. So the requirements for a near condensing boiler is going to be a Cat 4. So Cat 4 meaning UL 1738 listed stack. So most commonly, people listening probably would refer to like AL29 4C as a material that's acceptable for venting. And because we're running at an 88%, our stack temperatures are going to be higher. So in comparison, in condensing boiler, we might be able to use, PVC, CPVC, polypropylene. Because we're running at a higher stack temp at 88%, the only safe venting material for that application would be that UL 1738 stainless stack.
Gotcha. And I think I'm going just a little bit past 101, but I've heard of instances where boiler flues and it's the wrong material, or people are just like, it's fine, whatever. What are the dangers of not using the correct flue material?
Honestly, this should be 101. If this isn't 101, because flue is when it comes to problems with the boiler or making an unsafe installation, flues
or incorrectly sized flue too.
Absolutely, that you're going to have problems with combustion. You're going to have unreliable unreliable boiler if you do not have flue. A flue in itself should be its own podcast. So, and certainly I think that we're not a flue manufacturer, but I'm sure you guys could get someone on here to discuss that, right? Mm-hmm. And if not, I can probably find someone here for you too. But flue, I mean, especially in my background, it was so important. It can make or break your job. It can make or break your experience for the end user. It can make or break the project for a salesman, right?
Sure.
And I've thank goodness not witnessed this, but in the industry and talking with people, literally, the wrong application, putting in PVC in a design system for 180, 200 degrees, literally the PVC is melting and falls on people's skin. Right?
Oh my gosh.
So it's really important to pick the right material for the application, right? And, keep in mind, and when we're designing a system, PVC for every 100 feet has 4 inches of flex, and like a stainless product has 1 inch. So over time, if you're running a temperature that exceeds the limit of that PVC, it's going to degrade that product. And if we're getting 4 inches of flex, there's a significant chance that could crack. And then you're circulating flue gases within the building, and that is what like the nightmare scenario, right?
For sure.
So, that's why venting is so important, and especially when I'm designing, especially when I was working as a contractor, I never put anything in besides stainless venting, because the cost savings to me was not worth the potential risk of someone's livelihood.
Sure.
Or whatever. I mean, and when you get into the larger sizes, right? Single wall. If I can run up an existing chimney, I can run single wall vent. The cost of material might be different. Mm-hmm. But let me tell you, if you've ever worked with 8-10 inch PVC, that stuff is heavy.
Sure.
And if you're running that up 2-3 stories and you're having to figure out a way to brace that into existing stack, I found it much easier to run single wall L29. Mm-hmm. I could have 2 guys help, running that, and they're not busting their butt and breaking their back to do it.
Sure.
It made sense for me, not only on a project management side, but a safety side.
Sure. So I think that's a great kind of basis for boilers. Now let's kind of shift gears to talk about Camus boilers specifically.
Sure.
Just kind of give the audience a little bit of an overview of who Camus is and what you guys offer.
Yeah. Well, as I'd like to quote a former, I shouldn't say former, a salesperson, we're the choose your own adventure of boilers.
Okay.
We have everything from under the sun. It's from 60,000 BTUs up to 6 million and iron on much larger than that in the future here.
Okay.
From water tube to fire tube, condensing, we have products in copper, copper, nickel, and stainless. We have common products like, for example, our non-condensing boiler. You can get that in copper, copper, nickel, and stainless steel. Now, we're the only ones on the market that offers the traditional modular vertical boiler in a stainless steel. And it gives you that added layer of protection in a non-condensing system so that you're going to be able to, if for some reason parameters had changed and we're in a condensing mode, you're not going to route out your boiler, right?
Okay.
And that protection is very comparable to what the upgrade for a copper nickel system would be.
Okay.
Right. And on top of that, you get a full 10-year warranty on the stainless products. Right. So it's a significant advantage from us. But not only that, we have a 25-to-1 turn down on our fire tube boiler. So as you guys were talking about in the past, or just a little bit earlier about turn down in the marketplace, having that high of turn down has eliminated the need for a summer boiler, right? Because we can get down to, with a 25-to-1 turn down, we can get down to pretty much lower than what that system is going to require.
Sure.
Theoretically speaking, if we put a couple of these boilers into any application, we're going to be able to meet whatever the turn down needs for that system is. And we're able to maintain, on a 25-to-1 turn down, we're able to maintain our combustion efficiencies by maintaining a 1-to-1 air gas ratio. So you're not giving up you're not giving up efficiency to run at a lower firing rate, which is, traditionally speaking in the industry has always been in Scotch marine boilers has always been the case where, you gave up a little bit of efficiency to have that higher turndown.
So Brad, what is the direction and kind of the vision for Camus moving forward from here?
Yeah, we've got some big things planned. We're working on numerous projects that are going to be new things that we're going to be introducing to the market, which at this point we'll share them at a later date. Maybe we can do some lunch and learns or something
Sure.
with your guys's. But not only that, we've been diversifying our market. Not just playing in the commercial market, but we've also entered quite a bit in the light industrial or even the industrial market with providing processed water, heating for processed water needs all across the country. Work with wineries, meat packing plants, processing plants, paint booths.
Oh wow!
Yeah,
okay.
so we've done quite a bit of work with the processing side. I don't know if that's the direction, right? But we're diversifying our portfolio, and we plan to be able to offer and be the company that can offer a boiler for any application you need.
Oh wow. Brad, I want to thank you and Jeff for being on the show today and giving worldwide listeners a high-level overview of what boilers are and an introduction to Camus. Brad, if people are interested in Camus, where is the best place to reach out and find you guys?
Well, we use a rep system, right? So
Okay.
you can go to our website. On there, you can punch in your location worldwide, and it will tell you who the best contact for the location that you live at. If we don't have a representation, you can reach out direct to Camus. It will let you know if we don't have a representation as well.
And then selfishly, I would say if you are planning on designing a system to go into the state of Missouri or in Missouri and planning a system outside, I would reach out to Midwest Machinery. You can find us at midwestmachinery.net, and also look up Jeff Henderson on LinkedIn and Brad Carl, and give them a connect. And we post a lot of great content on there too. All right. Well, guys, thanks again for being on the show. And to all our listeners, keep engineering for tomorrow today.
Thanks for joining us on Engineering Tomorrow. If you liked the show, please take a moment to subscribe on iTunes or Spotify. For even more great engineering or construction knowledge, visit engineeringtomorrow.blog.